Hello everyone and welcome to We Meet at Digital Days. My name is Lisa Richter and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Wireless Power Transfer Enables IIoT. We cut the cord. Our speaker is Jem Som. He will hold a presentation and will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentation. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all of your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all of your questions promptly. At the end of the webinar, you'll be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and to help us to improve our event. You will receive the link to the presentation in the next few days, and a recording will be available at our website shortly. So now I will hand over to our speaker, Jem, and I wish you an exciting presentation.
Okay, hello and welcome to my session. Today I would like to present wireless power transfer enables IIoT. We cut the cord. My name is Jem Som and I'm the responsible product manager for the wireless power topics. I would like to thank in the beginning my colleagues from the wireless connectivity and sensors team, which are realized this hardware and software, which I would like to present today as well. Everybody of us knows kind of drones which will come up in the future. As you can see here in the presentation, I have a picture from Quantum Systems, and this drone, for example, is working completely wirelessly. All of these data can be sent out and received, for example, with the Wi-Fi or GPS modules, which are inside the drone. The only thing which is today not wireless is the charging function. That means we have to charge the battery directly, putting out and put them in the charging station. But maybe in the future, we can do this also wirelessly. In the beginning, I just want to give you a short introduction about what is wireless power transfer and how it can be realized. As you can see here, a standard transformer here in the picture. This transformer, for example, is a standard transformer with a ferrite core around. If we would like to have a look into the wireless power transfer, we just cut through the primary and secondary side, and then we have a transmitter coil and a receiver coil with an air gap in between. So that means the magnetic field is concentrated between these two parts, and we are transferring energy and for sure also data. Nowadays, more or less, we have two big possibilities, two big technologies in this we are transferring energy. The first thing is the inductive power transfer. That means we have one transmitter coil and one receiver coil. These are close coupled to each other with a magnetic field. In the distances up to 10 millimeter and in a working frequency between 100 and 200 kilohertz, or maybe at 85 kilohertz if we show automotive e-charging, these are connected to each other very closely. The second possibility is we have a very loosely coupled system where we have a resonance solution. There we have a transmitter antenna and receiving antennas. These are catching up the magnetic field in a bigger distance. So here are the distances are higher, and in the X, Y, and Z direction, we have a little bit more freedom. But in the inductive power solutions, we have a better coupling and higher efficiency. And here, for sure, you can imagine that the efficiency is much less. Today, I would like to give you some examples about what kind of applications are interesting to do. I would like to show you a little bit our 200 watt development kit, how to realize that. Our added values, our new LCD board, which is needed to enable the IIoT system, and proof of concept, which I will show you, and in the end, for sure, our support. The target today is to implement wireless power technology in your application and how you can do that. What kind of application could be interesting? First of all, any kind of drones, lawn mowers, for example, can be realized, and you are able to transfer not only data, also energy wirelessly. Additionally, some consumer products are also can be used in the future. So we have here, for example, power tools or a laptop. The agricultural drones or machines, which are completely working in alone and they can drive around, or in the inner cities with e-scooters and e-bikes. But also for higher power, for example, we have some cars or wheelchairs and other big vehicles which can be charged wirelessly. As a proof of concept, I would like to share with you this drone from Quantum Systems. Special thanks to this company which gave me a kind of this drone. In that picture, it looks quite small, but the size of this drone is 2.40 meters. As you can see in this picture, the drone itself can be splitted in these different parts. And here in this front case, this is the battery, and in this front case, it's possible to put in any kind of payloads. For example, Quantum System is using this as a for cameras. Here's a picture from my, let's say, in my office, in my home, and I built in this payload our 200 watt system. So here we have the transmitter board, here we have the receiver board. If the drone is landing on a specific space at anywhere you are, this is possible to program, then it's possible to charge them additionally. So don't have to remove the battery. Inside the payload, you can see the receiver board and here is the receiver coil and an additional board. This I just put it into here and the 3D printed case. And on top, as I mentioned, there's an additional board, which is the battery management system, which is needed to contact these wires to the battery. As you can see, it's quite easy, very simple to implement a development kit, for example, into a kind of system like that. The 200 watt system is almost a sinusoidal curve at the current profile, so we have less EMI. The resonance frequency and voltage can be regulated manually on automatic mode. The system itself, the concept can be scaled up to several kilowatts. As we using the Infineon MOSFETs with zero crossover points, that means we have a high efficiency over 90%, DC to DC. The voltages and currents can be scaled also. In our kit now, we're using 20 volts up to 10 amps. And we have included a bidirectional data transfer. The kit itself comes with a box, and inside the box you find that, as you have seen it in the picture before, transmitter and receiver boards, power supply, and the coils. All these informations are able to find in our application note in our website at 70 in the end. And if you have any additional questions or any open points, you can find it there. Important is, if you would like to develop your own software and you would like to change anything, you have first of all go to our website, and then at the point application node, GABA file schematic, layout, and current firmware, you can download everything for free. You just have to request the design files. You will get an email where you have to accept, and then you will directly forward it to our website again, and you can download the zip file. As you see, the amount is quite high because all these BOM, GABA file schematic, and layout are included in one zip file. How this looks like? You have to download from Infineon the so-called Dave software. Then you can use the software which you downloaded from our website, and you need a debugger from Infineon to connect it to the board, the XMC debugger. Here you can directly change your software, the regulation group, the data which can be transferred. Everything is for free and possible to change. What can we do additionally? As I mentioned, e-bikes are getting more and more popular. But all of us, we know that the battery is working at 36, 48 volts. For this, we have a BOM change. So please get in touch with us if you would like to use a 36 or 48 voltage at the output, not 20 volt like the standard what is the design kit is having. Then we can help you to adapt the needed parts. Additionally, as you have seen, the layout and schematic files in GABA files, they are at PDF. If you want to have the original Altium files, for sure, on request, we can support you. As mentioned before, the kit itself is up to 200 watts. If you would like to use higher power, for example, this is also possible if you increase the voltage, but the current will be stay low. In this case, you have to use a new transmitter and receiver coil, as this used parts getting too hot with eddy current and uh, proximity effects. In this case, we have a new coil. It's a little bit bigger. It's 70 millimeter outer diameter, but thicker Litz wires, and you can use this coil up to 400 watts. How to enable now the IIoT? First of all, we have to set up an LCD board. This LCD board will show you an end-to-end system, and it's an additional board for the 200 watt kit. It is not working alone. As mentioned, bidirectional data transfer is possible. So we have the 200 watt kit as mentioned. In the kit, we have our receiver board with the coils, transmitter board, and the sensor boards, for example, temperature and pressure, and the new LCD board. As an example, the sensor is connected via I2C. The data will be transferred over the wireless power coils to our new LCD board. In this picture, you can see that the coil is vice versa. It's just for the picture. In reality, it must be flipped down for sure. All this information about the LCD board you can find also on our website, wirelesspower/LCD. As you can see at the LCD board, for example, we can show the voltage and the current input output, the power, the efficiency, the temperature, and the pressure. At that board, you can see also we have a debug connector and an XMC controller, the same XMC controller which we are using at transmitter and receiver board. And you are able to program and change this LCD information what you want. Of course, we try to populate as much as possible our WE components. Also here, all the data, BOM, GABA file, schematic, layout, and the new firmware you can download from our website. Important is, if you would like to use the LCD board, you have to program the transmitter and receiver board because of the data which are going into this must be enabled at the XMC controller. The LCD board itself, it is already programmed for this functionality and you just have to plug in. As mentioned, applications are industrial IoT, environmental controls for climate chambers, for example. You can get it online, the board. Also here, how to get the software. Also again here, please go to our website, click on new firmware for TX and RX, and here directly a pop-up window will appear and you can download the software. Here you can see the software is bigger than before because of we have the transmitter receiver board software and LCD board software. And you can also again put it into the Dave software and reprogram and change everything what you want. Now how it works, I would like to show you a live demonstration. So I hope so. This is working right now as it is really live in my home office. First of all, I would like to take my webcam as a GoPro and show you my system, what I have here. As you can see, this is the receiver board. Here's the load. This is my sensor. We are transferring the data over the sensor over the wireless power coils to the transmitter boards. Here we have our LCD board, which is connected to the wireless node. You can see the blinking, the data will be transferred. And from the wireless node, we go by our WE protocol to our Wi-Fi module. I will have some slides later on. The Wi-Fi module is just connected with a battery pack and is connected with my mobile as a hotspot and sending the data which are created at the sensor board here to the cloud. So hopefully it will work now, and I will show you a live change. Let's see if it is working. By chance, it is not working as maybe my hotspot at home is not so good and I cannot get the data right now. But this is not a big issue. I will show you this on my presentation. In the presentation, you can see the data which are going to the cloud at the dashboard for the Azure website that I can directly see the temperature and pressure values which are going up and down if I'm pressing my finger to the sensor. That's live, yeah. It's not working right now. I don't know. Maybe I have a bad mobile net and it's not working, but normally I can show you this here. How this works, where the data is going on and what's going on. First of all, as I mentioned, we have the sensors and the I2C interface is sending the data to the receiver board, and with an in-band data transfer and ASK modulation, the data will be transferred to the transmitter. As mentioned before, we have a feedback loop and the data from the transmitter board is modulated with FSK, frequency shift keying, to the receiver board and demodulated the amplitude shift keying data here. Via the UART interface, serially, the data will be transferred to the LCD board as I have shown before. From the LCD board and the UART interface, we can send the data again to our wireless node as a feather wing. The wireless node, in principle, or let's say theoretically, up to 65,000 nodes could be used in a factory, for example, to collect the data. With the proprietary WE wireless transfer protocol, we're sending the data by 2.4 gigahertz to the Wi-Fi module, which is, as you have seen, connected with the battery pack. With the standard Wi-Fi protocol, we are sending this data to the cloud. And as you have seen, or more or less seen, the data will be shown up on our website, or you can just use any smart or mobile device. The feather wings, which I mentioned already, is in this case, we have an Taiwan 1 here as a gateway, which is, as I said, working with a 2.4 gigahertz proprietary protocol. And the gateway. In this case, we have again a Taiwan 1, which is receiving the data, and the Calypso is sending this to the cloud. And these two, we call it the IIoT enabler. because this system makes it smart. Additionally, I have shown you the dashboard. The dashboard we can help you to implement. So if you would like to do it with Microsoft or Amazon web applications, we can help you to set up this dashboard. As we have everything at GitHub, where you can get a step-by-step documentation and code examples how to realize it. Here is the link, the GitHub with Elektronik Feather Wings link. The Feather Wings itself, we have 5 different of them built by our own. So we have a sensor feather wing with the different kind of sensoring methods, temperature, humidity, pressure, and so on. The Tyon 1, as I mentioned before, for the proprietary system, the Calypso for the Wi-Fi, a power module with magic power modules from WE, and the microcontroller boards. The benefits, yes, you have a rapid prototyping, you have a sensor to cloud, you make a dumb application to a smart IoT application. You can use the microcontroller and program it by yourself, and it's super easy, Lego-like to build on different blocks. And for sure, hundreds of other Fruit Feather and Spark Fun are available in the market, and you can combine them. What our next steps are going to be? Our next steps will be that we have realized a new application node 84 that, as I mentioned, the data is now transferred from the in-band to out of band. In-band ASK, FSK, but we have a very limited data transfer protocol. If we would like to increase from 500 bits up to 848 kilobit, we are using an NFC antenna. And for the NFC antenna, we have a combined coil. This combined coil is a wireless power coil and an NFC coil. And in this application node, we're describing how to do the impedance matching for this NFC coil, which is needed on top. For sure, for our wireless power transmitter and receiver, an additional add-on board is needed for the NFC. We are working on that, and we are very, very sure that we will release this in this summer. If you want to have a little bit more information about wireless power transfer, we have our book, The Trilogy of Wireless Power Transfer. I have it here on my bookshelf. You can see every time if I have need some information, I can have a look on it. And for sure, you can also order it in our website. If you need additional support, as I mentioned before, you can go to our website for the wireless power, where you find the application note, the schematic, the software, or you can directly contact your local Würth Elektronik sales team or FAEs, or send us an email to our wireless power hotline and the subject 200 watt kit. And if you need for the wireless connectivity boards and sensors help, please contact us on the WCS support website or the digital.engineering email address. And in the end, for the dashboard and also for the feather wings, you will find the software and the step-by-step documentation at GitHub. In the end, I just want to say nothing is more powerful than an idea whose time has come. Thanks a lot for your attention, and if you have any questions, please, I'm ready. Thank you.
Thank you very much, Jem, for your great presentation. Like you already mentioned, we will now take a look at a question. You've got now also the chance to just write a message or a question via the chat function in the panel. And let's have a look at the first question. What is the maximum power to transfer with the development kit?
The maximum power with the development kit, if you buy it, is 150 watts, as we have a 150 watt power supply in the box. And this reason for that is obviously easy. First of all, the coils which we are using are getting too hot if we are getting over 150 watts. And the box was too small for a 200-watt power supply, so we just have a 150-watt. But in general, the system itself, you can use it up to 200 watt if you use a lab power supply as an example.
Okay, thank you. Then there is a question where they can find more documentation, for example, the bomb or something like this.
All these informations you can find in on our website we-online.com/wireless power, and then you can just go to the sections 200 watt kit, and then you go to the firmware. Then you can download all these documentations, as you mentioned, software and hardware, description, the manuals, the flyer, everything is over there available.
Okay, great, thank you. There is another question. What has to be considered to certification according to CE marking, RED and safety directive if we start with 200 watt VPT prototyping or samples for customers?
Okay, so this system is not certified or red, so we have not a CE marking on this. We are working on that, that's true. And we did our, let's say, the first EMI measurements, and it looks very promising and good. But right now we have not a CE marking on the boards. And the red and safety directive, for sure, we do our measurements there and our own EMI lab in Waldenburg, as we have in our headquarters the possibility to do the measurements. And if you are implementing the system in your system, you have to do your own certification and measurements anyway. But here also we have experts, FAEs, which will help you if you have any kind of issues.
Okay, thank you. Another question, where can I see the data at the cloud?
Again, I didn't get this question again.
Sorry,
Can you repeat it?
where can I see the data at the cloud?
Rare. Yeah, you can. In my example, we created an own Microsoft Azure website where we are sending the data to this website over with our Wi-Fi module Calypso over my hotspot, which today didn't work already quite well, but in general it works. And this website you have to set up by your own. And if you need help for creating kind of dashboards to see this data, have a look in our GitHub or get in touch with our wireless connectivity team.
Okay, thank you. Another question, what is the maximum amount of wireless nodes?
I think it's application node. I think so. Maybe this is the the question. I don't know what the wireless nodes mean. I think the application node. So we have, I think, on the web 4 or 5 different application nodes, which describing different applications from basic to advanced. And the newest one is I mentioned the NFC topic, impedance matching. I hope this will answer the question.
Yes, I think so. Another one, what's the distance range between transmitter and receiver?
The maximum distance in our system is 10 millimeter. As we have limited this to a worse or less coupling that we will stop transmitting energy. This can be programmed by yourself as it's a development kit. For sure, you can increase the distance, maybe 15 or 20 millimeters, but then you have to accept the lower efficiency and lower coupling. But in general, this depends on your whole system, how big are the coils are, how much distance you're allowing, and how much efficiency you would like to achieve.
Okay, thank you. And maybe a last question. What is the status on the availability of industry standard for these applications, even though most solutions are currently developed using proprietary solutions?
So maybe the question is, there is not an industry standard right now. We have this, as mentioned, CE and EMI certifications and also the RED. That's clear. The standards itself at the WPC, they are working for the Wireless Power Consortium. They are working also in this power classes like mid-range, so over 30, up to 200, up to 2.2 kilowatts. But they are still working on the standard. So in the market, there is no industry standard right now. That's the reason why we have set up this proprietary system to give a very easy step into the wireless power technology for your application up to 200 watt applications.
Okay, thank you very much. So I think we finished now the presentation. If there are any questions left, we will answer them via email afterwards. Thank you very much for your attention, and I hope you enjoyed our presentation. And the next presentation topic is Würth Elektronik reveals the question about optocoupler phototransistor types. So hopefully see you there and enjoy our digital days, and goodbye.
Thank you. Bye-bye.